Hi guys, today we're on Unit 9, Lesson 7, and we're on our third day of solving trig equations. So our first problem, we're going to solve for x on the interval 0 less than x less than 12. And our instructions here say no calculator. So we're going to have to kind of treat this like one of the solutions that one of the types of equations that we did yesterday. When I look at my actual equation, I see I have a multiplier in front of my x. So even though it's scary, even though it's pi over 6, that doesn't matter. Just leave it alone. A equals pi over 6x. And start with that. So now we have cosine A equal to 0. So if you remember, this just means we're finding the angle whose cosine is 0. Right? This is our reference angle, so to speak. And if we think about our cosine curve, because our function value is a 0, and that's one of our quadrant angles, our solutions are going to be A is going to equal pi over 2. A is going to equal 3 pi over 2. 90 and 270. Okay. Now, why did I convert these? Why did I use the pi's? Because when I go to replace A, I realize that I'm dealing with pi's in this equation. So it might make sense to write my reference angles in terms of pi. I know we haven't really done much of that yet. So now if we want to solve for x, all we have to do is multiply by the reciprocal. X is going to equal 3. Uh, 6 over pi. And x is going to equal 9. And with this type of problem, we're really not going to, and I know it's hard for you to understand, but I'm not going to worry about the repeated solutions. I mean, I could. Let me just think about this for 1 second. So 2 pi divided by pi over 6. So my solutions are going to repeat every 12 units. So if I add 12 to 3, I'm already going to be outside of my interval. Okay, so we really don't have to worry about these repeated solutions, so to speak. Okay, and this is what I meant yesterday. Okay, this is actually came from a calculus problem. And this is how they generally set them up, that you're able to solve them on a given interval and you get your solutions. And that's that. Okay, that's how easy this is. Okay. Now, this above example can also be solved using a calculator. When we use a calculator, we want to make sure we're in radian mode and we adjust our window to the given interval. So I'm going to review, right? We're going to start with our original equation. And we're going to talk about the steps we're going to use if we decide to use our, if we're told to use our calculator. First of all, we want to be in radian mode now. So I just try to remember, whenever I'm dealing with the graph of a function, I want radian mode. I don't know if you could. I don't know if my face is in the way. So I have cosine pi over 6x. I'm in radian mode. And now if I'm not given an interval, I'm just going to graph this on Zoom 7. And that would be my solution. However, for this, that would be what the interval I'm solving for. However, in this equation, we were told that we want to be on the interval 0 to 12. So I'm just going to adjust that so I get my picture. So if you could see there, you're actually solving for 2 x-intercepts. So we're going to plug our equation into y1, right? And then what we're going to do, adjust your window. And now we want to find the x-intercepts. So we second trace 0. And it's going to ask for a left bound. I've got to figure out where my cursor is. So I'm going to move along the x-axis and get close to that x-intercept. Hit enter. Right bound. Hit enter. And my 0. Right, so left bound, right bound. And after you hit that, your 0 is going to come up on the screen. So we have 1, 0 at x equals 3, which matches what we got algebraically. Now let's find the other 0. Now, if you're doing this on your I-83, there might be one extra step. I think you have to hit enter one more time. And we will deal with that if anyone has any questions. And my second x-intercept is at 9. Okay. So you see, you get the same answers, whether or not you use the algebra or the calculator. If f of x equals cosine pi over 6x, oh, now let's go back to our calculator screen for a second. Remember, x equals 3 and x equals 9. Those are our x-intercepts. Our graph kind of looks like this. Now, there's going to be a lot of times in calculus where you're dealing with problems where you're going to have to describe the intervals where the function is greater than 0 or where the function is less than 0. Okay. So if we wanted to describe these intervals, we could say the interval of the graph is above the x-axis from 0 to 3 and 3 to 12. And it's below the x-axis or less than 0 from 3 to 9. Okay. So sometimes when I give you a calculator problem, just for you to get used to what's going to happen in calculus, I may also add in something of this nature. Now we're just going to solve each equation using a calculator. So I have x plus 5 cosine x equals 0. My calculator is already in radian mode, so I'm just going to plug in the equation. X plus 5 cos x. Okay, so this is what's going to go into y1. And I'm setting it equal to 0, so I'm going to graph it. Okay, now remember, my calculator is adjusted to the previous problem. So I'm going to go back to Zoom 7 to kind of readjust it. Okay, I was not given an interval here, so I'm going to solve on the Zoom 7 screen. So I have 1, 2, 3, second trace. We're going to be looking for 3 zeros. I got to just bring my cursor. I know I can tap it. Someone told me I can do that, but I can never figure that out. Left bound, right bound. So I have one x-intercept at negative 1.3, 3.837. Zero. I'm going to get this guy now. $1.977. Okay, and notice I'm going out 3 places. And remember, this actual answer is radian measure. Okay. So 1.977 would be, whatever that would equate to in degree measure. Probably about what? 60 times 2, about 120 degrees, give or take. And our last x-intercept is going to be negative 1.306. And that's really it. Okay. We know in calculus, there's going to be times that we just solely rely on the calculator, and sometimes when we have to do algebra. So you'd have to know the difference between which method to use. In example 2, I have x squared minus 2 sine 2x equals 3x. So I'm going to get everything to one side, set it equal to 0, and I'm going to solve it on the interval 0 to 2 pi. So remember, this is your y1, and then you're going to use your second trace feature. I'm going to graph that. I'm going to go to my window, make sure I'm between 0, 2 pi. Okay. X min is 0, X max is 2 pi. Go back to the graph. So I'm actually only looking for one. Actually, there's going to be 2, right? Because 0 is included. So second trace, 0. I don't know if it's going to let me solve this because I don't think I have another. Because I made my window a little bit too. Enter, right bound, enter. And my 0, if you see, it is at 0. It's kind of obvious from the picture. So I have one x-intercept at 0. And my next x-intercept. $2.148. And I'm just gonna, so we can answer the next part of this problem, just gonna kind of bring my picture onto my paper. So I wanna describe my intervals. Remember, this is a 0 and this is a 0. Describe the intervals where the function, now this is gonna be our function. I know it looked a little bit different to begin with, but once we have it set equal to 0, that becomes our function, where f of x is greater than 0. So that's going to be from 2.148 to 2 pi. And I can include 2 pi. Okay, I can't include 2.148 because my inequality sign is strictly greater than. And f of x is less than 0 from 0 to 2.148. Let's try one more example. I know this is very repetitive. I should just let you do this one on your own and see if you get the same answer as me. 6 sine x minus e to the x. I forgot to look carefully. This has to all be to one side. And I'm on the interval 0 to 5. So I'm just going to go ahead and adjust my window to begin with. Look at my graph. And I see here that I'm going to have 2 x-intercepts. So I'm going to go ahead and solve for them. X is going to equal 0.762. X is going to equal 1.349. And again, I have my calculator here. I have my screen. So I'm just going to kind of make my picture. Remember, those two x values are these values here, your x-intercept, where your function, right, this function you made is equal to 0. Where is f of x greater than 0? From 0.762 to 1.349. And where is our function less than 0? 0 to 0.762 and 1.349 to 5. Again, if you put parentheses instead of brackets, that's really not an issue at this point in time. Okay. Before we leave today, there's one other problem that we didn't really get to, so I would kind of like you to add this in. And this is going back, this is not really going to be, this is going to be solve algebraically, meaning no calculator. Let's say I have something like this, sine theta minus 3 equals -1 over sine theta. I didn't really do anything like this, so I would just kind of want to go through it with you today. So basically, I'm going to make that left side into a fraction, and then I'm going to cross multiply. So I'm going to get sine squared theta minus 3 sine theta equals -1. And I hope you see how solving a trig equation is so similar to regular equations. Get everything to one side since we're dealing with a quadratic. And now we're going to try to factor this. But what you're going to see is you don't have two numbers that multiply to 1 and combine to give you -3. So we can't factor this. And I don't think we've dealt with a problem like this in this unit yet. So what are we going to do when we can't factor? We have to remember our quadratic formula is a useful method to help us solve equations. So when we apply the quadratic formula, we get sine of theta, because that's our variable, equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So our sine of theta equals 3 plus or minus, this is going to be 9 minus 4, which is the square root of 5, all over 2. This is really two situations here. Sine theta equals 3 plus radical 5 over 2, and sine theta equals 3 minus radical 5 over 2. How do we solve for the angle? Remember, second sine. I want the angle whose sine is 3 plus radical 5 over 2. I'm solving for an angle, so I want to be in degree mode. I know that's tricky, okay, but I'm not using. So second, do I want to be in? Oh yeah, second sine, and I'm doing 3 plus radical 5 divided by 2. And that's going to be not a number. And if you think about this, 3 plus the square root of 5, so the square root of 5 is 2 point something, right? 3 plus 2 is 5. 5 divided by 2, this number is approximately 2.5. We actually could have got the number before we did this, but this is going to be no solution. And let's look at our other, I'm just going to kind of bring it so we could see it with the calculator. So we want a second sine, the angle whose sine is, let's do this first then, this time. 3 minus radical 5. 3 minus radical 5. And I'm going to divide that number by 2. So I want the angle whose sine is 0.3819, whatever. So I second sine, pull in that decimal, and the angle here, our reference angle, is going to be 22.4. We'll go out 3 places. We're trying to be good about this in a calculus sense. So actually it would have probably made more sense to get your decimal first, because remember, when we're solving for the angle, we want to find the positive function value. So it really would have made more sense for me to evaluate each of them and get the decimal value first. Going back here, my reference angle is 22. My function value is positive 22.456. That's my one solution. The sine is positive in the second quadrant, so I just have to find the value of this angle. 180 minus 22.456. So this solution is 157.544. So I just wanted to kind of give you guys a little practice with something that, involves using algebraic methods that you guys already learned and should remember. Okay, so the quadratic formula is always a go-to method when you're trying to solve equations and you can't factor. Alrighty, thanks guys, see you soon.